Data engineers that don't actually impact decision making are just running up cloud bills and moving bits around in the cloud without actually having any tangible impact. In this 2-hour course, we're going to be covering all of the things necessary to land an impact as a data professional, whether that be pushing back with stakeholders on low value requests, because the whole "can I get this data real quick" meme is a meme for a reason, and data engineers get burnt out from that over time. And so how do you push back there so that you can have more time to do robust data modeling that actually impacts decisions, not just for this quarter or next quarter, but for the next 4 or 5 quarters? And along with this stuff, we know that another layer in impact is communication and visualization. If you can display your data in a very compelling way, that is a very powerful way to impact decision-making processes. I'm excited for you to check out this course. This is the last of the courses in the 6-week free data engineering bootcamp, so I hope you enjoy it. The types of impact. You got measurable, hard to measure, and immeasurable. So if you think about measurable, it's you made a pipeline more efficient, congratulations, or you enabled an experiment to run that moved a metric. That's another easy way to have measurable impact. It's like you provided metrics that moved, that enabled an experiment to run, and that experiment caused these metrics to move. So you can claim some of that impact. Usually you need to claim that impact in collaboration with data scientists and product managers and stuff like that. You got to do that. Like, it's not like it's just yours, unless you're like a data unicorn and you're doing all of that. And I'm hoping that most of y'all will have more of those skills, kind of those experimentation skills as well, as you kind of learned a little bit in the bootcamp this time. Then you have hard to measure. Quality improvements. For example, if you don't have any data quality errors, like one of the things that's hard about measuring errors is it's like nothing going wrong is the measurement. The measurement is 0. The measurement is like no problems. And obviously you can measure those things. You can measure like how many errors are showing up and all that stuff. But like, and that's why it's hard to measure, because it's not necessarily that like you can't measure it. It's just that like, is it worth your time to actually measure it? Like, and in my experience, like most of the time in big tech, the answer to that question is no. Like they don't really keep track of like all of the quality errors that happen and how many are happening on each team over time. So that can, and because the thing is like the number of quality errors is not necessarily indicative of the quality, because you could also have more pipelines. It could be indicative of the number of pipelines, or it can be indicative of the amount of data quality checks that you're doing. So like more quality errors might actually mean higher quality, because you're actually catching more bugs. So that's where like that measurement is a very hard measurement to figure out. And that's a good example of something that matters. I mean, I'd say data quality matters, but it's also something that is tricky. Team enablement outcomes. That's another one. So I'm just going to give a quick example here about team enablement things. Something that I did at Airbnb or at Netflix that made my life a lot easier was I wrote this Groovy script thing that what it did was it made the amount of data that I had to ship to run my Spark job a lot less. It like cut it by like 60%. So then instead of taking 4 minutes to deploy, it took 1 minute to deploy. And I was able to get that code adopted across the team. And so we all saved some time. But it's hard to know how much time we actually saved. I mean, the only way we'd be able to do that is measure like how many times does each person on the team deploy, and then multiply that across the board. And obviously that's like probably some amount of time. Like, and I tried to get a kind of a back of the envelope calculation there, but it's not something that you have like the hard numbers for, and or would I ever like create a data pipeline about, right? I would never actually like spend the time to actually go and measure the impact of that improvement, because the value of measuring that is not worth it. Like, and the back of the envelope calculation is probably good enough to give you a good enough measurement, but like it's obviously not very accurate. So, but it's still impactful, and it's something that can definitely saved a lot of headache for my team. But whether it's good or bad, or whether it's measurable or not, is like, and how accurate that measure is makes a big difference. And then obviously you have the third type, which is immeasurable impact. The big one here is changing intuitions, where if you present data to someone and then like if you present data to a leader and then it changes their intuition on how to make decisions, that can be one of the most impactful things you can do because it makes it so that their default thinking is more correct. But that is very hard to measure. Like the only way you could measure that is if you had leadership take some sort of like bias test, and like they're not going to do that. And so changing intuition is a big one. Team culture improvements, like if you're a good team player and you're very enjoyable to work with, and all that stuff, that's another way to have a good impact. But like it's one of those things that is again, you could almost put this in the hard to measure because you could say like, okay, it's a measurement of retention, but then you have like team dynamics where it's like you might be the best team player ever, but like if there's another person on your team who's toxic or your boss is toxic, then like you might be adding to the culture, but then the other people on your team are removing from the culture, and it's like, is the fact that there's massive, attrition on your team, is that because of you, even if you are the person who is the person who's actually contributing a lot to the culture? So I put it in the immeasurable bucket there because team dynamics are very complicated. But that being said, that doesn't necessarily mean that you shouldn't be a good team player because it is something that matters. The last one here is called being a glue person. I found being a glue person to be a very important piece of this puzzle. What I mean by glue person is you're kind of the person that holds the team together, and you do a lot of the work that is not like as shiny or as sexy as like a lot of the other work. Like for example, one of the things I did to be a glue person at Netflix was I combined all of our team's code into one repo, and then I showed everyone how to use this like single repo, and that was a great way that I got everyone on the same page to for code sharing. That was cool. I found that to be a really fun and great time. But like at the same time, it's like, what was that? What was the value there? The value there was mostly in the collaboration model, not necessarily in like, oh, I saved Netflix n number of dollars because now we are all using one code base. It's like very hard to measure. Very hard to measure like what the difference would be if we use 10 code bases and like how much time we would save. It's a very hard one. You know you could see that there's impact there, but you don't know what it is. Like you don't know exactly like how many dollars it is or how much money they're going to save or how much time they're going to save. You don't really know, but you know that there's impact there. And that's why being a glue person is super important, because like if teams don't have glue people, they kind of fall apart, and then you just have a bunch of like really talented lone wolves who don't support each other, and that can be very terrible. And I've found that like the glue people are the people who get promoted to leadership. The glue people are the people who actually end up becoming managers and leaders because they are very good at banding people together. Whereas the lone wolves, like sometimes they can be good too. They just like are more like, I think they're more likely to become very technical ICs because they can be kind of a lone wolf in those cases and kind of build up that way. But even then, it's tricky for if you're working in that lone wolf mindset to get promoted beyond like senior engineer, because of the fact that if you're at staff or higher up on the ladder, then you also need to lead and band people together and kind of sell people on a technical vision. So like it's very hard to work alone and become a leader. That's just kind of, I hope that makes sense. Like the leader who is alone, that like sounds like an oxymoron, and it kind of is. And that's where like there's a lot of value in being a glue person. So I know I've just harped on that a little bit, but yeah, let's keep going. Okay, so how does your time as a data engineer translate into value? Well, there's a bunch of things here. I think the number one way that people like as a data engineer, like if you if your grandma asks you, so what do? You like say, oh, I supply information to the business. I think that's like what most people would say is the kind of at a very fundamental level. That's what data engineers do. They supply insights. I think that is one of many things that they actually do, and there is going to be a lot more that they can also do as well. That like it's not just supplying insights. That like there's so many other tasks and ways that data engineers can have impact that is super important. Obviously, you have preventing bugs and maintaining data trust. Because if you have, if you're in an organization that has low quality data, then people are just going to use their intuition more, and their intuition is oftentimes a lot more likely to be wrong than right, and that makes the business, it's riskier for the business because data is also wrong a lot of the time. Like, I mean, but like it's wrong less of the time than your intuition is, and that's the whole point and why we use data and why we like data. Also, like pipelines aren't free. You need pipelines that are efficient. You gotta make you can save a lot of money if you make your pipelines efficient, and you either save a lot of money or you save a lot of time because like if there's an error, if you have a very efficient pipeline that runs really quickly, then you can bounce back from a data quality error a lot faster. Like for example, when I was working at Airbnb, one of the things I did was I added a staging step to the pricing and availability pipeline. And the old pipeline, if you wanted to backfill all of history, it took like 2 weeks. And with the staging step, it went from taking 2 weeks to taking 1 day. And so, and since it only took 1 day, like we were able to iterate way faster on the definitions of pricing and availability at Airbnb. And I also didn't feel so nervous about making mistakes because my pipeline was a lot more efficient. And so like I didn't have to like eat all of that backfill pain of 2 weeks of like babysitting my pipeline and hoping that it doesn't break by just making the pipeline more efficient. So that's another great way that you can have a lot of good impact. And I know that the next data engineer, he's going to be very happy with that, whoever took over my job at Airbnb. You also have enabling other engineers to work faster. And this can be in a couple different ways. One of them is through processes like code review. If you provide code review that helps people adopt best practices more consistently, then that's a great way to work faster because then you're just, it goes back to point two here of preventing bugs and maintaining data trust, right? Because if you use best practices, you're going to prevent bugs and maintain data trust. And if you prevent bugs, you're going to work faster because you don't have all the maintenance overhead that you would normally have from bad data quality. So that's going to be another great way to think about it. But there's all sorts of other ways. There's so many other ways that you can enable other engineers to work faster. I want to go over a couple more here. So I talked about that thing that made it so I could deploy my pipelines faster. Another thing I worked on at Facebook was I worked on this framework called Milky Way. And Milky Way allowed you to do all sorts of analytical patterns, essentially for free. So how it worked was you described the schema of your input table, and then you described the analytical pattern that you wanted to apply, whether that be and almost all the analytical patterns that were available in Milky Way we have covered in this bootcamp. One of the analytical patterns was cumulation, like cumulative table design. Another one was growth accounting, or that kind of state change tracking. Another one was retention, kind of retention tracking. So that's one of the reasons why I wanted to cover all that stuff, because I found those analytical patterns to be heavily used at Facebook. But we built a framework that made it so you didn't have to write the SQL for that. You just had to describe the input schema, and then that was it. And then everything else would be done for you. And so that enabled data engineers to work a lot faster. It was like almost like the Chat GPT of 2017, where we were able to just be like, yep, apply this pattern with this schema. Take this schema and this pattern, and then you have your output data set. And so that was really fun. But that's another example where you can build frameworks and libraries that enable other engineers to work faster and better and with fewer errors. Like you can think of like another example here is like if you have engineers like for example Max Bjoichman, he worked at Airbnb, and he created Airflow, and he open sourced Airflow as a technology because he was like, the orchestration engines that we have right now, Oozie is terrible. I don't want to write my ETLs with XML. XML is terrible, and like it's painful, and like I want to be able to use loops and expressive stuff, and that's where you get a lot of that with Airflow, and that's another way that Max enabled people to be a lot more effective. And obviously that has been, you can have that be a very high level. If you think about like Max's impact there, it wasn't just at his own company. because airflow is used like across the entire industry. And so if you want to really be at that next level, that's what you want to do, right? Um, that's going to be the next one, right? If you are building things that make it so other engineers can work faster, that's going to be some of the most impactful and important work of your career. Last one here, I think, is important as well, which is around kind of like shifting culture and shifting decision making processes. Because a lot of times, companies, like if you're not in big tech and you're at other companies, like they might not be as data driven as big tech is. And so you want to also spend some time to not just like show like, hey, here's this high quality data, but also be like, yo, this data is like, you should be making decisions with this data. And if you're not, like, you're flying blind and you're taking on unnecessary risk to the business that you don't need. So anyways, those are going to be like the 5 ways that you can essentially change your time for impact and time for value. And the more effective you are at each one of these buckets, the more you're going to uh, be a better data engineer, and you're going to climb the ladder faster. Especially like if you can learn how to do every single one of these buckets effectively, then you're going to climb really quickly. But we're going to dive a little bit deeper into each one of these buckets because I think it's important. So, so when is an insight valuable? When you create a data set, right? Like for example, one of the things I did right in that experimentation week last week, and I did that red and blue experiment. One of the things that I learned from that experiment is that really it doesn't matter. It doesn't matter if it's red or blue. It really doesn't matter. And so if it doesn't matter, then that kind of goes into that third category of it fails to support or contradict intuitions. Because I predicted that the red button was going to do a little bit better, but like statistically speaking, they are exactly the same. So, but you can reinforce intuitions, contradict intuitions, or kind of like fail to reinforce or contradict intuitions. You can do all three. And that can be a very important thing to remember, is that no result is a result. Like, especially when you're doing experiments, like if your experiment says there is no relationship between these two variables, and when like that, a lot of times, like data scientists, they might consider that experiment like a failure, quote unquote failure, when that's not the case. Like you learn something. You learn that like these two things are not as correlated as you thought. That change doesn't matter that much. So like when you fail to reject the null hypothesis, like that is still a valuable thing. I think data engineers and data scientists, they get into this kind of rut when that happens, though, because it comes back to that measurable versus immeasurable impact. Because when the null is rejected and there is a statistically significant result, then you can measure that result and you can say this many dollars, this many users, this many revenues, and that is good. But like when you don't reject the null, like the answer is like it doesn't matter. Like the change doesn't matter. Like, and it has no tangible impact. And so that is something to think about. Like another thing to remember here in data engineering is supplying insights in general is often overvalued. I think it can be a big part of our job, and it often is. Like it often is like a very, very big part of the data engineering job. But it's not everything. And a lot of times I think there's people out there in the world who think that it is everything, especially analytical partners. Analytical partners oftentimes will be like, hey, can you just pull this data real quick, or that kind of meme and everything. And because it's not often that like supplying insights is just quick and easy. Okay, so here are some signs that your organization is overvaluing insights, because insights comes at the expense, like the rate at which you create insights comes at a trade-off with the rate at which you create technical debt. And there's a balancing act there, where if you want to just churn out pipelines every day and like not really care about quality, and you just want to like have a bunch of data points, like you can do that quickly. I could create 50 terrible pipelines in a month, all right? And I could do that. And they might have like the data might be 80% right. And like it could give us directionality even. Like in the startup world, that might be a good play, because it's all about like getting answers as quickly as possible, but like you also want to remember that you want to create your pipelines and all your stuff in a way where once you build it, it can stick around for a long time. So if you want to come back to it, you can do that. So I'm going to talk about. I have a couple anecdotes in on this slide as well for when an organization is overvaluing insights. Because analytical partners, they when business is normal, analytical partners are very patient for the most part, and they are going to be like, okay, we can wait, we can get in with your long-term planning or your quarterly planning, we can get in on that. But that all kind of goes out the window when something crazy happens. So I'm gonna give one example real quick. So when I worked at Facebook near the end of my time there, like Facebook saw its first dip in growth ever, and that was what was considered a crisis. And I essentially got pulled off all of my normal work I was doing, and I got put onto this like squad to troubleshoot this crisis as quickly as possible. And um, I learned a lot from that process. Initially, I felt very excited to be a part of that because I felt very important. Where I was like, "Wow, I'm going to troubleshoot this very hard problem." I learned later on, as I've kind of done, and as I've had more of these crises in my career, that like I don't know, I don't necessarily think that it's like the best thing to do because it's like you end up creating a lot of pipelines that might be low quality, or like you're not taking enough time on them because the analytical partners are not patient enough, and that can be a problem. And so one of the things that happened for me is like I know I churned out like so many different pipelines and measurements and stuff like that, and that's when I like kind of discovered different patterns. And that's where like in these crises, like if you're churning out a lot of pipelines, you should be able to notice like some higher level patterns, like maybe that if you go back to like week 2 when we were talking about daily metrics or weekly metrics or monthly metrics or slowly changing dimensions or whatever. Because most of the time when a crisis happens, what analytics is looking for is the ability to slice and dice and cut the data in every possible way that they can. And if you're doing your data engineering right, that usually means that you don't have to do anything and that data is just available for them. And that like that's the long-term vision for data engineering, is that like you build the data infrastructure for them, and then they can answer whatever questions they want to answer, and you don't have to go and write ad hoc pipeline after ad hoc pipeline and burn yourself out. And so, anyways, for me, that's what happened. Like I was writing like these ad hoc pipelines and trying to solve these problems, and like I got so burnt out. I felt so tired from working on this all the time. And one of the things that I realized was that I was overvaluing insights and I was undervaluing tech debt and my own sanity and all sorts of other things, right? And so that's where it's important to think about things in a longer term vision. And that's another thing that can happen, right? Is in a crisis, like a lot of times it's more like I need this answer tomorrow or I need this answer yesterday, and you don't have like, oh, I'm gonna deliver this to you in 2 weeks or 3 weeks, and then like it's gonna be like there's like a vision for what you're gonna be doing for the next couple days or the next week or two, and you get this kind of like I need to sprint the marathon sort of thing. I think we talked about that a little bit earlier last week, but um, and then the last one is ad hoc request hell, where you just have so many requests coming in, and you don't know which ones you need to actually fulfill and which ones are not worth it, and which ones like should be passed or delegated or like even like removed from your task list. So a lot of that like ad hoc requests, like hopefully that's something that you can work with your manager on, and you can get a good kind of way of like getting the stakeholder to do the upfront work. Where because a lot of times I've noticed with ad hoc requests, if you make it so the stakeholder has to do more work themselves to give you a request, as opposed to them just being like, hey, can you pull this data? Because that's like easy. It's very easy. That's a very low effort for them to make a request. Like if you make it so that there's a little bit more of a barrier for them to make a request, where they have to fill out a doc or fill out a form or fill out something and like explain like why they need this data and all that stuff. That stuff that can be a great way for you to have a healthier relationship with your analytical stakeholders, because then you're not just like running around like a chicken with your head cut off, and you can actually plan ahead, and requests come in at a slower pace. because because they don't want to do it because like they don't want to, they're only going to make a request when they really need it in those cases because it's work for them, and that's a good thing. It's one of those things that I kind of went back and forth on for a while because a part of me feels like, well, we shouldn't slow down business communication, but this is something, especially in data engineering, that I think is kind of unique to this because software engineers already have this. They already have a lot of this. Like, okay, you want a new feature? Okay, put in a request. It's not like, oh, you want a new feature and we're just going to give you that data tomorrow. Like they don't do that. They don't do that, and I think that that's one of the things that's changing in data engineering is it's becoming more like software engineering, where you can kind of have more of that long term planning, and so that's a key thing to remember here. These are the four things that can happen when when it looks like your organization is overvaluing insights. That is the big thing to remember here because we're talking about value here. We're talking about impact. So in this case, this is these are four signals that you can see that would be important to see that your company's probably has the bias a little bit wrong and is a little bit out of whack. There's another example I have actually for a crisis. So I worked at Netflix in 2019, and in 2019 that was when Disney Plus came out, and again that was another example of where people were freaking out because they were like worried that like Disney Plus was gonna like take over and be really powerful and all this stuff, right? And again, we had some more like analytical, like really intense analytical sprints and stuff like that to like solve problems. And so you can have all sorts of different things that can happen in your company. And remember as well that like these crises will pass, and don't take them personally. Like, because I definitely felt like when I was working at Facebook, at least, that like I needed to solve Facebook's growth problem like by myself, or like I needed to do everything in my everything I could possibly do to solve this problem. And I don't know. I think that that was like I definitely over indexed on like trying to solve this big problem when like I probably should have focused more on like myself and my health and my well-being. But anyways, that's those are overvaluing insights indicators. So how do you push back? Pushing back and saying no is so important because if you just say yes to everything as a data engineer, you're going to get burnt out. You're going to get roasted. You're not going to last very long here. I mean, a lot of people in data engineering don't last very long. Like many people, I think a lot of people drop out. I think it's like 80% of people drop out in data engineering after 5 years. So why? This is a big reason right here. So don't be afraid to say no. Don't be afraid to push back and tell your stakeholders that things can wait and that like you're doing things as quickly as you can and while maintaining quality, obviously. And push back, say no. I love saying no. Say like that's like one of my favorite things in the world is to tell people no, that like it can't happen. And that can be a beautiful way to remember that like you're in this career for the long term, and like if you're getting all these requests that are happening on this like weird lurchy short-term basis, you're not going to stay in data engineering for the long term. You're not going to at all. Like, and so that's a big thing. Leverage your manager. Always, if your manager should be able to support you in these in saying no and getting the prioritization right. If they don't, find a new manager. Like find someone else, quit the job, find a new job. Like because if they aren't able to like help you like maintain a good sanity and a good work life balance, it's not the job for you. Um, Obviously, another big thing here is around you want to communicate with your stakeholders about the fact that like if we go slower, we can go faster. Because if we can build comprehensive and robust data models, then all of these one-off pipelines that they're asking for don't even need to exist, and they can just query the data and it's just available to them. And that's where like if you have robust data models, like it's very powerful. It's insanely powerful. It saves your own sanity as a data engineer if you can get these robust data models, because then a lot of the analytical partners, they don't need one-off pipelines anymore. They can just go to the data and query it themselves. They might need help with like some of the querying, like they might not know how to do those like array functions or anything like that if you're doing like one big table, but maybe you can teach them, and then once they know, then you can you're good to go, and then they won't have to like bother you anymore, and you can again focus on more robust data models. And that stuff is very powerful. And the key takeaway from this slide is remember, don't be afraid to say no. And that like the odds, like, I think that a lot of data engineers have fear about that because they fear like they're going to get fired, or they fear that there's going to be a fight, or they fear that there's going to be like, I don't know, some sort of pushback. And that's not what happens. I've generally found that like when you when you push back, that's when you get the most value. Like, and because then you actually saying no to something opens up the possibility of a conversation about priorities, and opens the possibility of a conversation around sustainable work environment. And so, because saying yes does nothing. Saying yes just gives them their value. And like, if you keep doing that, you're gonna eventually burn yourself out. So those are some good antidotes to when insights are overvalued and you're kind of treated like a SQL monkey. These are going to be great kind of tips that I've used in my career to kind of maintain balance. Okay. Some of this stuff we talked about in week 3, but how do you maintain trust in data sets you produce, right? Quality checks, obviously, you got to do write, audit, publish pattern. Documentation, write a spec, just like what we were talking about before, because this trust, remember, trust is the impact here in this category. And then you have good engineering practices, use cumulative table when you can, minimize the amount of data that you're processing, and all that stuff. Clear expectations, make sure you have like an SLA so that people are aware of like what is when this data will arrive, because that can be another way to minimize like communication overhead, because people are like, oh, is this data delayed? It's like, nope, it's only delayed if it's been over a day, or it's only delayed if it's been over 8 hours, or whatever your SLA is. And so, and then also document the gaps. I think that this is an important one to talk about real quick. So sometimes people might see your data set as like all powerful, and that like it's they put more trust into the data set than they probably should. And that is something that you don't want. I don't know if y'all ever saw this thing with Zillow. They've tried to like predict the housing market. And they spent like hundreds of millions of dollars on the housing market in places, and they lost a ton of money. And so that is an example of where they had data sets that they believed in, but those data sets were not complete. They didn't cover all of the nuances of the housing market because that's a very complicated system to model. So that's going to be an example of a gap. And hopefully you can think about like things that might not be in the data set that could make the data more accurate. But that's going to be around clear expectations. Um, I find data trust, it's interesting because this area I think has kind of gone back and forth, and it really depends on the organization whether this is overvalued or undervalued. I found at Airbnb it was like accurately valued, like it was like very fair. Facebook it was undervalued, where like Facebook they really did care about just like they overvalued insights and they kind of undervalued data trust and data quality. And Netflix was kind of more like Airbnb, where they kind of fairly valued this. But generally speaking, there's a lot of companies out there that like really just want you to give them a number, and they don't really care as much about like the sustainability, maintainability, or trust of that number, which is weird. I found that so weird that's the case. Like why? Like, oh, don't you want to care about like whether or not you can actually trust this number? So, anyways, quality is an undervalued way of delivering impact as a data engineer. So remember that as you're kind of going throughout your career. So what about efficiencies? Efficiencies and quality are related. Efficiencies is almost like a subset of quality, but we talked about a couple of these things. Proper data modeling is a great way, right? That was weeks 1 and 2. If you data model correctly, you're going to save a lot of time and pain and frustration. Improving on call. If you're in the combined track, like we did a lot of stuff last week on data pipeline maintenance, and so that's going to be a great place to see what you can do there. Um, Reducing data volumes. This could be like through sampling or compression techniques, like leveraging Parquet format. We're also going to be covering a lot of Parquet stuff in the Spark week this week. It should be fun. Picking the right tool for the job. So I think this is an important one to talk about real quick. I have another anecdote for y'all. So when I was working at Facebook, there was a big push to get off of Hive because Apache Hive was like the main big data technology we use because Hive is slow and expensive and terrible. And they were like, okay, we need to move to Presto. And I was like, okay. And one of the things about Presto is if you have more than 1 terabyte of data, uh, Presto is going to run out of memory because Presto had like a 1 terabyte memory limit. And I was like, well, my pipelines are like 10 terabytes, so uh, I guess I can't use Presto. And that was like kind of a crazy thing for a little while there where I was like, what do I even do? And I was like, I want to make my pipelines more efficient, but I can't use Presto, and Presto is what Facebook wants everyone to move to. And so what I did was I waited a bit and then I talked with the data platform team and I was like, yo, can we get Spark? Can we get Spark on my team? Because I know if I get Spark, I'll be able to freaking process my data way more efficiently if we move to Spark. And then I got access to Spark machines, started migrating things, saw a massive improvement. But you see, like, one of the things about this is like picking the right tool for the job. Like, I did try Presto for a while. I actually did try to use Presto for wherever I could, and I was like, this is dumb. Like, this doesn't work. Like, and like Hive, literally the older technology was the better choice in those cases. And like I was surprised by that because I was like, I thought Hive was old and slow and terrible, but like it was old and slow and terrible, but it actually ran. So like that was made it better. So you never know what tool might be the right one. Like I've definitely noticed this as well when moving stuff from Hive to Spark is that like Spark can actually in some cases be more prone to running out of memory because it leverages a lot more like RAM compute, and because of that, Spark actually can fail more often than Hive. So in some cases, it's not a clear trade-off. It's not just like, oh, it's so much more efficient, but it could fail more often as well. So you want to be careful when you're like migrating and upgrading and being very aware of the trade-offs that you're making. Okay, so another thing to think about here is like simplifying model and reducing capabilities a little bit. So sometimes your data science partners like they want you to have every column under the sun. Like a lot of times it's like quote unquote like just in case, and then like you put it in there and then you regret because like then you look like after 6 months they've never queried it, and you're like, okay, why did we bring this column with us? Like why if they've never actually used it? And it's like, oh, are they we put this column in for the one chance that they query it one time in 5 years? I don't know if that's worth it. I think that that's probably not worth it. And so that's where obviously there's you have to be aware of like the impact of these things. um like for example, there was I have a kind of a trait. I have an example of like the other side, right? Of like when that line of thinking actually doesn't work. And like that was like when I worked at Netflix and I worked in security, I worked a lot on like security audit logs and like auditing like if a security incident happened. And in those cases, like those logs are not queried that much. They're only queried in like in the case of a security incident for the most part. And those didn't happen very often. So in those cases, like, yeah, it makes sense to have that data on hand. Or like another example is like maybe you need to hold on to data because of legal reasons or privacy reasons or things like that. Or um, and if you need that, like then that makes sense. Like if you're like bound by law, then that's fine. I think generally speaking, the way I look at it is like if it's like something related to security, legal, or lawyers or privacy, then there's going to be probably more of a flexible nature of this number 5 bullet point. But if you're in pretty much anything else, like then you really want to think about whether or not to bring in the column, because if so many times data scientists have told me like just in case, and then they never query it, and so in those cases it would probably be better to just not have the column, and there would be no downstream or any sort of impact from that.
Congrats on getting to the end of the day one lecture. If you're taking this class for credit, make sure to switch to the other tab so that you get credit for it.
What I want y'all to do is, there is a repo. You'll see in here, there's the data 6 data impact training repo that I want y'all to be looking at. So essentially what we're going to do is we're going to be doing a text file today. And this is not going to be too bad. So you can either pick events or devices. It doesn't matter. We're going to go with events. And then what we want to do here, this is just so that we can create an aggregated data set. And so in Tableau, you can do joins like in the workbook. Generally speaking, I don't consider this best practice, but I like this for this case in particular. So all you want to do is you want to drag devices.csv onto there, and then it will try to guess, and it's going to say, oh, we're going to join on device ID, and it's like, that's right. So we're good to go. That's essentially it for kind of how we're going to be building out some of our dashboarding stuff today. And then I don't know if y'all have ever used like Sheets before. Now I'm just going to kind of go over kind of the higher level kind of features of Tableau real quick, because I think some of y'all might not know this. But so you have on the left here, you'll see some of these things are blue, right? You see like ABC, 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 all these blue guys. These are what are called dimensions. And then the green ones are measures. And there's actually the only measures in this table are counts, like because this is again just like website device hits. So like for example, if I drop in, let's drop in host here. So, or we'll put it down here in rows. So this is like every host that is on the website. One of the things you'll notice is that this is every person that has ever had a tech creator account, essentially. And this is probably not that useful of a visualization quite yet. But like if you add in the events, and then this is looking a little bit better. Like you'll see that some of these lines are a lot bigger than other ones. But then the cool thing about this is like if you go down here, you'll see there's like a little sort button. You can hit sort here. It's like pretty great. And so then now you can see like, okay, here's zachwilson.tech, exactly.com, admin.zachwilson.tech, techcreator.io, all these different websites that have they all have some people have more hits than other people. You'll see for the most part, it's like mostly me and then Sarah's got about 1,700 hits, but then it's mostly like Lulu, and then everything above here is mostly me, and then like tech creator, right? And then obviously exactly.com. This is like also all the traffic that y'all are creating. So this is essentially what kind of data set we're working with. This data set is every single website request that exactly has gotten. So one of the things though is that I want to show y'all is that like there's many things that you can do with this. Like, so I don't really like this long tail. So I think I really want to focus on like 1, 2, 3, 4, 5, 6, 7. I care about the top 7. So let's go ahead and create a filter, because I think filters are pretty cool. So if you go to host and you like right click on host, you can go to create set, and then you can create host set. I'm going to call this top 7 hosts. Go to top, and then you say by field, and then you say 7, and you say okay. Okay, so now we have top 7 hosts. And so you see how now that filters it down. So now we just have the top 7 hosts. And so this is like probably a nicer kind of list of things to look at. So one of the things that is pretty cool about this is this actually has way more dimensions in it than you would expect. Like, for example, so this chart's kind of interesting, but like one of the things that this chart doesn't really show is there's not really a good time dimension here, because one of the things is like if you notice, like if I put time into the filters, you'll see that the data here actually goes back to 2019. So let's just look at 2023. And you'll see that like, and you'll see zachwilson.tech is now lower than exactly.com, because exactly.com, I started leaning more into exactly.com this year and last year, and like 2019 to 2022, I was all about zachwilson.tech, but then I freaking, this year I moved back over. But you see how I then filtered down to this is just 2023. But there's so many cool things you can do in Tableau, right? So you can also just like say like new worksheet, and then I want to show you just some other cool things you can do. So like if we say, okay, we have a year, and then I want to filter to the top 7 hosts, and then I want to color by host. I want to add. Okay, so here are all the hosts. And then what I want to do is I want to put a line chart. Okay, so now this is now a line chart of all the hosts. And you'll see that like really it's just a battle between exactly.com and zachwilson.tech for the most part. All the other kind of tech creator domains, they have gotten like an order of magnitude less traffic. But like one of the things about this is like this isn't that good of a chart because like what if I wanted to look at the proportion of the traffic as opposed to the just the count? So what you can do is you can go here, you can say add quick table calculation, you can say like percent of total, and then you can say what is this, compute using table down. And now this is but the chart here, this is not the right chart. So now this is going to be more around which one. Oh wait, this is not quite right. This should be, can we do cell? Or is it, it's both. I think it should be event time and using event time and host. There we go. There we go. Now it adds up to 100. Okay. So you'll see, like, over time, you can see how the proportion between the battle between like zachwilson.tech, exactly.com, and admin.zachwilson.tech, they all kind of like battled it out, and you can see kind of how like exactly kind of like pushed out in this in the most recent year, and so yeah, you can kind of like see things in a very clear way. One of the things that's interesting about this data though is that like you can cut at whatever grain you want very, very quickly, right? Like, so I want one more chart, and then I think I'll open it up for a little bit of questions. But then we're going to be also obviously we're going to be going way deep into Tableau on Wednesday as well. One of the things that's cool is you can actually go to you can go to very fine grain here. So you'll see here, this is now at the daily grain. You can see how we have you can see all the days of data and like when people were like hitting the website, and like, and you'll notice that there's like a lot of hits on these two dates. So these two dates are the dates that I announced on LinkedIn that I was quitting my job. All right, you can see I got a lot of traffic, and now I'm starting to ramp back up here. But like, that's kind of the idea, right? Is you can definitely see how like it's kind of taken off more, and how there's going to be more of a kind of a bump there. But obviously, like, I like to again look at this chart more like with it broken out, where you have the different kind of domains to look at, and you'll see that like, okay, like it's cool because like you see like with Lulu, like you can see Lulu's see those two spikes, the May 26th spike, and then this one here, this August 14th or this August 11th spike. Those are the two those are the 2 days where I did my streaming contest, right? Because you can see like Lulu generally speaking like gets no traffic like at all. But then like if when I'm like, no guys, you gotta check out Lulu's website, you can check it out, right? So anyways, that's kind of the idea. We're going to be building out a lot of cool visualizations and stuff in Tableau, and I'm hoping that y'all can do this.
Congrats on getting to the end of the day 1 lab. If you're taking this class for credit, make sure to switch over to the other tab so you can get credit for the day 2 lecture.
Let's talk about a couple things that I've noticed, bad practices that people have done when they are building their dashboards. So a big one is don't do joins on the fly. Like if you have two data sets and like you're trying to query something and you're like, give me this data and then do a join and then dump it out. You can do that like if the join is tiny, like if it's like one side is super tiny and it's not going to be very, not a big cost. But if the join is like if both sides of this join are like substantial at all, then don't do joins. Just don't do it. Like just pre-aggregate, denormalize and pre-aggregate. Like when you're in the dashboard, you shouldn't be thinking about master data or scalability or freaking any of that, because you're at the final layer. Because when you're in the dashboard, like there's nothing downstream of the dashboard besides the human. And so, if you have someone looking at it, like, then it should be as crunched down and refined as it can be, because there's not going to be anything that's going to be like reading from your dashboard. So don't join on the fly. It's terrible. Also, like if you can do pre-aggregate your data sets. I think that's another really powerful thing that can make your dashboards really, really, really performant. We're gonna not like. There's actually a trade-off here for pre-aggregated data sets because on one side you have when you pre-aggregate, you lose like a certain layer of detail that you might have if you have all the dimensions of all the individual rows. But on the flip side, it just loads instantly. So like if you like, especially I remember at Facebook when I was building out, like I built out a lot of very fancy visualizations at Facebook. I built out the family of apps visualization at Facebook, which is I was the very first engineer at Facebook to integrate all the metrics from Facebook, WhatsApp, Instagram, and Messenger. And we had like one visualization that showed all of that data. And like if you think about it, if I didn't pre-aggregate, then the number of rows that each day of data there would have would be like 4 or 5 billion for each user. And it's like, the dashboard's not going to load, fam. It's not going to load because it's like, that's for one day. Like, think about like, oh, we want to show a 30-day line chart. Okay, now instead of 5 billion rows, you have 150 billion rows, right? And it's like, good luck, right? So in those cases, you want to aggregate down. And then you can aggregate down to like a certain grain. And if y'all remember, we talked about in the advanced SQL section of this bootcamp, we talked about grouping sets. Grouping sets is very, very, very powerful in making your dashboards a lot more performant because then you can pick the dimensional grain that you want and you can have multiple dimensional grains that you can look at and you can build a lot faster dashboards that way. So definitely things to think about. Also, another thing that I've noticed is sometimes I saw this at Facebook and at other places is people like to use like stupid stores for their data. Like they like to query S3 directly, which S3 is like kind of cold. Like, you know how like they say Apache Iceberg sits on S3 and Iceberg is, I don't know if you know, but icebergs are not hot. Icebergs are pretty cold. Like, you know, like if you like, you know, watch the Titanic or whatever and like Titanic crashes into the iceberg that was in the Arctic, kind of cold, not fast, not hot. So you want to do not using S3. You almost never want to build your dashboards on top of S3. You want to move the data into a lower latency store. Druid being the best example. And obviously now since Jitendra was here, I'm going to have to make a shout out to Pinot. It sounds like another really cool option that you could use as well. So make sure that you do that because like if you do both, if you like use Druid and you pre-aggregate and you don't use joins, you do all three of these things, your dashboards will load instantly, always. Regardless of the scale, regardless of the complexity, they will always load instantly. And even if people change filters, they change stuff like that, you will have a very fast and performant dashboard that people will love using. So remember to think about the end user when you are building out your dashboards. Because if your dashboard is slow or kind of hard to use, then people are just going to not use it. I have a statistic for you. You know that 85% of dashboards in businesses are used one time or less and then never used again. So that's like a terrible, terrible number. Just letting y'all know that's a terrible number. Like it's so, and the big part of that is because they don't think about these things. They don't think about investing in quality or completeness. But then obviously the dashboards that are used can be used a lot. So you want to understand the different ways that things can work here. But these are your best practices. So remember those. These things are not as important to remember as don't use pie charts, but they're up there. Okay, how to build dashboards that make sense. So one of the things that I would do when I was building out my dashboards at Facebook was I was thinking about, okay, who is this dashboard for? And if your dashboard is for executives, it shouldn't have any interaction for the most part. Like it should just be like your charts, your lines, and you have one story to tell. Like essentially if you're giving a dashboard to an executive, the dashboard and a screenshot of the dashboard are the same thing. And that like there's not like you don't have like as much like interactivity. Analysts, on the other hand, want almost the opposite. They want tons of drop-down filters. They want to be able to slice and dice and kind of like really hunt with the data sets. So this is where for analysts, like if we go back to the performant dashboard kind of best practices, you might end up not pre-aggregating for analysts because they might be able to have more complex filter conditions if they are not pre-aggregated, and you can have like they can kind of do more root cause analysis if it's not pre-aggregated, and for them, they understand if the dashboard is a little bit slower because it's doing something more complicated. So just a thing to think about. The big thing to remember here is who is your customer. If you build, it kind of works both directions here. It's like if you build an executive dashboard for an analyst, they're going to be like, well, thanks for the one number. But then it's like the other way around. It's like if you build an exploratory dashboard for an exec, it's like, thanks for like all the filters that I'm never going to use. And so they both kind of cut both ways. So definitely that's going to be a big thing to think about. So knowing who your customer is really does determine the design that you would be thinking about. Okay, what are the types of questions that can be asked? So let's talk about a couple different types here. These are going to be the main types of questions that you are going to surface up when you write your dashboards and do your visualizations. So first one here is going to be top line questions like, how many users do we have? How much money do we make? Right? How much time are people spending on the app? Like stuff like that. Then you have trend questions like, how many users did we have this year versus last year? Right? And you could think of like trend questions. They almost always have that. They have some sort of time component to them. That's going to be the one thing that's very important with them. Whereas top line questions have essentially no dimension, right? Or they might have a filter, but that's about it. They might be like, how many users do we have total in India, right? Or something like that. And that would be like a kind of filtered top of line. But that's kind of like, that's where it's interesting between top of line and composition. Because composition is going to be like, okay, what percent of our users are Android versus iPhone? Or like different things like that, where you have like what percentage of our users is male versus women, and different things like that. So this is good. We're going to go a little bit deeper into each one of these types of questions because they're all very kind of important. But what numbers matter here? So these are going to be a mix of top of line, composition, and trends. So like you have total aggregates, right? Total aggregates is just like the total number, right? I love the number I love there is the total aggregate. I like to talk about is if you just do count star from number of humans or from all humans on Earth with no dimensions, right? You get like 100 billion. There's been like 100 billion humans on this planet. That's a lot of humans. And then you have time-based aggregates, right? So you could say like in that case you could say like, okay, you could do count star, but then in that case, from humans, then you group by like this year, and then instead of getting 100 billion, you get like 8 billion, maybe a little bit more because a lot of people die this year as well. So like it might be 8.1, 8.2 or something like that. But like you get your time-based aggregates that way. And then you get time and entity-based aggregates, where in this case, you could say like, okay, how many alive humans do we have? So then you do just get that 8 billion number. Or it's like, how many alive humans do we have this year? That's like a good thing to think about. I was like, that's another aggregate kind of metric that you can have. You have derivative metrics. So this is a good one where it's like, it's just like year over year, how many humans are there? Like, so, in the US, like, we're like plus 1 million or plus 2 million or something like that. Like, that's how many more humans are in the US this year than compared to last year. So you get that, like, derivative metrics are very powerful. They are, when I was working at Facebook and I built dashboards for executives, they actually didn't care about the total numbers at all. They actually asked me. So the original dashboard I had for them was the total numbers. Like, Facebook has 2 billion, WhatsApp has 1 billion, Messenger has 1.2 billion or whatever. It's like just those up and to the right charts. And they didn't care about that at all. They only cared about year over year. Like was the growth accelerating, decelerating? And they cared a lot more about the derivatives so derivative metrics are interesting because they are a lot more sensitive to change than just normal aggregates are. So like if you look at a chart and you look at the derivative, it's going to be a lot more like volatile than just the normal aggregate is. So, and that can be very powerful in charting because it can help you pick out trends earlier. And that could be a big thing. I don't recommend day over day derivative metrics because day over day is like, you have a lot of weirdness, especially with like Friday and Saturday. And then you also have Monday and Sunday. And like, because there's weekend versus weekday, and there's usually like a seasonality to the week. And so like your day over day metrics are usually pretty volatile and insane and don't really have a pattern unless the trend is very, very strong. And then you have other types of metrics, dimensional mix. Like for example, in my newsletter, I have 33% of my subscribers are in the US, 25% are in India, and then the next biggest country is like 4%, and it's Brazil. I know Bruno's in this call, so shout out to Brazil. And then we have Android versus iPhone. That's gonna be another big one that people like to battle about, and there's all sorts of other dimensional mixes that you could think about. And then we also talked about retention and survivorship. That's something that we talked about in the analytical stuff as well, which is its own type of metric, which is like, it's kind of like a dimensional mix though. It's like the percent of users who are still this dimension after this amount of time. So one of the things I want to go over real quick about dimensional mix that can be interesting is sometimes these numbers can change. But like the dimensional mix can change, but then the total aggregate stays the same. Like for example, when the Ukraine war happened, I'm sure the number of Facebook users in Ukraine dropped a lot, but they didn't drop overall because they just left. Right? They moved to like Poland, or they moved to like Russia, or they moved to other places in Europe. And they kind of fled Ukraine. And so like that's what's called mix shift, which can happen where it's like if you have a metric that's tied to a dimension, then sometimes that dimension specific metric can drop, but that drop actually doesn't have any impact on the business because the value just changed. It's like because you're tying your metric to a slowly changing dimension. And if you tie your metric to a slowly changing dimension, and then that dimension changes, that user is still there. It's just that they don't have that same dimensional value anymore. So you want to be, that's one of the things you want to be careful about when you're defining dimensional mixes, because that can happen more often than you would think. Like it happens all the time. So that's a good thing to think about, like mix shift. So these are the most common kind of visualizations and charts that you would see in dashboards. So yeah, let's go to the next slide. Why do these numbers matter? Total aggregates. We're going to talk about each one of these in more detail here. So total aggregates is almost always reported to Wall Street because it's like, Airbnb always reports number of bookings. Bookings is the number that Airbnb reports. Facebook reports active users, but Facebook changed, right? So here's a great example of how Facebook changed their reporting to make Wall Street happier in some regard. Is Facebook no longer reports on the number of users on the Facebook app. The only number they give to Wall Street is how many users they have on the family of apps. So on Facebook, Instagram, WhatsApp, and Messenger, they don't give the app by app breakdown. They only give the total aggregate to investors. One of the reasons for that is because the blue app, like the original Facebook app, like wasn't doing so well, all right? And there was a couple times when it didn't do so well and investors fled Facebook, right? And so this goes back to when we go back to like what I was talking about in this previous slide about dimensional mix is you have dimensional mix and mix shift. And a lot of times these users are still actually on a Facebook product. They just moved from the Facebook Blue app and now they're on Instagram. Or they moved from the Facebook Blue app and now they're on WhatsApp. right? And they just aren't on the Blue app anymore. But Meta and Facebook Meta, whatever, they still actually have that user. They just don't have them on that app specifically, and they're not tied to that dimension anymore. So that's a great example of where when you're reporting these total aggregates, a lot of the time you don't want to report dimension specifics because those dimensions can kind of change. And these total aggregates are very important. It's like how much money are they making, and then and all that kind of stuff, right? And these kind of just give a current state. Like obviously another one is like revenue, how much revenue they made in the last quarter. That's another very common metric or aggregate that gets reported. So think about total aggregates. Good numbers to think about. You have time-based aggregates. These are going to be a little bit different, right? Where you can catch trends earlier this way. A bad quarter is the potential signal of a bad year. You can see that happen. I mean, I don't know if y'all saw Facebook stock over the last year. It went from 300 to 90 back to 300. Some crazy stuff. And these charts, it's all about growth and trends and like where is the stock going. That's what these time-based aggregates are going to be. So time and entity-based aggregates. These are not usually reported to Wall Street, but they are often plugged into A/B testing frameworks, and they're used for a lot of that kind of stuff. And data scientists like to look and cut this data up and slice and dice to figure out like why metrics are going down or like what is going on to get to like the root cause of things. So that's important. But keep in mind that these metrics are not very often actually reported to Wall Street because of I gave a good example of why. Okay, so we have derivative metrics. So derivative metrics are great. Like I love them because they really illustrate like where the growth is headed for the company, and they're more sensitive to change. I like to use percent increase instead of absolute increase because then you can get a better idea of like the numbers that are going to happen. And investors usually care about percent increase instead of absolute increase. And year over year growth, that was the only number that Zuckerberg cared about that I worked on. So that was like the big one that he cared about. And it's funny. So when I worked at Airbnb in 2021, we were working on year over year stuff, but we actually changed all of the metrics because of the pandemic. Because like if we did in 2021, if we did year over year in March, like March 2021, then it's like, wow, like we have 700, 800% growth. Like we're doing great. But it's like, that's actually not what's happening. It's just that like the year before was terrible. And so that's why these derivative metrics are more sensitive, right? Because they are subject to changes on both ends, where it's like the previous year's delta and the current year's delta, they both impact the year over year number. So that is actually dependent on the delta of two numbers, and as opposed to like the total aggregate is based off of just one number. So that's why you double the sensitivity when you do use year over year. And so what we did was instead we did year over 2 year. So we compared in 2021 we compared everything to 2019, and we kind of did that for a while for 2021. And then in 2022, we actually migrated it back to year over year. And it was like we just did year over 2 year for a little bit. And so because we just didn't want to compare against when everything was shut down. So derivative metrics, they matter a lot. We're going to be looking a little bit at those in the dashboarding session we have today. Dimensional mix is great. So a big thing here is like, for example, like I know when I worked at Facebook, they cared a lot about like growing in the developing world, and that's why they came out with like, I don't know if y'all remember like Facebook Basics and like the internet.org, where they're trying to give the internet to like people in India and people in Africa and stuff like that, because they want to get everyone on Facebook. That's kind of their idea. And because they look at the dimensional mix and they're like, you look at like census and population data and they're like, wow, we only have like 2% of the people in this country. But the main reason for that, and then Facebook's like, okay, why don't we have people in that country? And then it's like, oh, not very many people in this country are actually on the internet yet. And so obviously that's changed quite a bit. That's changed quite dramatically since I worked there in 2016. and because the world in general from 2016 to now has become dramatically more online across the globe, which is a great thing. But obviously, there's still more improvement we want there. We have to have all the memes. I need to know all the memes. I need memes from everywhere in the world. It's important to me. And this is going to be where you can also spot trends in populations. That was one of the things that I noticed when I was working at Facebook was like, oh, like you could spot a trend like, oh, Ethiopia shut off the internet. And it's like, oh, we lost all our growth in Ethiopia. But it's like that trend, and that fired a bunch of data quality checks and a bunch of data quality errors. But it was like actually real. That's just like what the world was doing at the time. And so you can spot trends like that and understand things, right? Dimensional mix is really great for root cause analysis as well. So say you see a dip in a total aggregate and you're like, why is that number going down? Then you look at the dimensional mix and you're like, oh, it's going down even more like in the US or even more in iPhone users, or like, and you can kind of find like the subset population that is impacted the most, and then that can help you figure out like what is actually going wrong. And like in the Ethiopia example, it was like, oh, we saw the total aggregate dip a little bit, but then it was like 100% in Ethiopia, and then everywhere else we were seeing growth. So that was a great example of a spot where that can kind of happen. So dimensional mix, important. Remember, dimensional mix and mix shift. Those are words that you want to be aware of when you're doing your visualizations and metrics and all that kind of stuff. We talked a little bit about retention and survivorship in the class. We're going to just talk about it a little bit here. This is like the number of days, the percent left after n number of days. Like, I don't know, like what there's, I think there's 41 of you in this lecture today, and the number of people who actually survived this boot camp, right? I think 41 is dramatically lower. I think the number, because we had 130, and I think there should be 100 in here. So I think like half of you, or a little bit more than half of you, died. But we still got 40 of you in here, which is impressive that y'all made it so far. But survivorship analysis is important because it helps you see like the long-term value and like the lifetime customer value. Lifetime, like customer LTV, is another very important metric that your business needs to have.
Congrats on getting to the end of the day 2 lecture. If you're taking this class for credit, make sure to switch to the other tab so that you get credit for it.
We want to think about things a little bit. So one of the things we want to think about is what questions do we want to describe, and how do we want to display data? And we're gonna put a couple charts together, and I think that will give us a good example. So one of the things for me, because this is real data. This is the data to my website. One of the things that I care about a lot is where are people coming from? And that's actually in this data set. You'll see this referrer column here. You see if you drop referrer, it's going to get very upset because it says there's 1,400 different referrers. So let's put that in the rows here, and you'll see that there is like just an insane number. But a lot of these are actually just like on site. So you see how like if it's like it's exactly going to exactly, or like there's all sorts of different like on-site things. But you'll also see, let's put a count in here. So the way you put count in is you grab this and then you can put him here, and then you can see the total numbers here, and you can see like, okay, LinkedIn is obviously where I get the most. But you see how there's like 2 here, and both of these are actually LinkedIn. So, and there's probably even more that are also LinkedIn. So what we want to do here is we don't like this. This is terrible, right? Because there's like so many. There's just too many. Like we want this to be like maybe 10, not all of these, right? So what we want to do is we want to create a calculated field that's going to define this stuff. And really, this is something that probably should happen upstream, but I'm going to show you how to do it in Tableau. So what you want to do is on referrer, if you right click on referrer, you could say create calculated field. Okay, so this is going to be called, we're going to call this referrer mapped. If contains this, right? And we say else if. So let's get all of the LinkedIn ones first, because there's a couple. You see this like LNKD? This guy's also not gonna like work the way that we would expect. So let's put that guy in here. I'm gonna give you this as well, right? We can put LinkedIn, then LinkedIn, right? And then we have we have else if there's like a is null referrer, and then this is then direct because they might not come from anywhere. They might type the website in directly, and so that's what that's gonna cover, right? And then let's do a couple more else ifs here. So we have contains, and then referrer, and then you have Instagram, then Instagram. We probably want Google as well. Why is that like so weird? So then we have Google, then Google, and then we have you see this t.co? T.co, that's Twitter. That's actually what Twitter does. So I'll say this is Twitter. And then we have in this case we also have exactly, and this is on site. We also have Zach Wilson. This is on site. And then this is we also have there's no, it's just those two. So I think whoa, what is going on here? There we go. So we have exactly Zach Wilson. Okay, there's Bing. Do we care about Bing? Well, Bing is like high enough up that we probably do care about Bing. I guess there's YouTube. Oh, look, there's Stripe. This is like all the people who bought, right? Who were coming back from the Stripe checkout. Okay. Okay, I think then we just have an else here. And then we can say else, so we can put other. So you see, this is terrible. But then if we move this and we put referrer mapped, okay, now this is looking pretty nice, right? You see how we have all sorts of kind of connections here, like because if you have the referrer, like do not add, because if you put the referrer in there too, then that should give us, yeah, see, null is just the most common way that people go. Apparently they just hit the site directly. So one of the things to think about here is, okay, so this is a good example of what I would call, this is going to be like our traffic by source. So what I want to do is I'm going to rename this sheet. We're going to call this traffic by source. So that will give us a nice name for this sheet. So this is pretty good, and you'll see we can kind of see exactly where things are going to come from. Really, like on site is kind of like not even like one that we should probably even include, because it's like they're already on the website. We care about external traffic, but we're going to keep both of them in here for now. So this is a good chart, but it just kind of shows total aggregates, right? So let's make another chart here where in this case, if we have event time, I don't like year, because year is kind of a it's very bulky as a dimension. So I like usually like month. So this is going to be, now we have, this is going to give us like, so if we put a line in here, we put the count. So now this is going to give us like our actual chart, our month over month kind of chart for the traffic of my website. You'll see like, wow, these were almost exactly the same. That's wild how those peaks are almost exactly the same there. So this is going to be the monthly traffic to my website over time. You see I have data going all the way back to January 2019, and you see I like it's kind of slow, and then it's just kind of gotten out of hand over this year, right? It's interesting, these points right here, this point, and this point are all very important points, which I'm gonna which we can talk about, and we will put into kind of the storytelling that we can put in here as well. So one of the things that I think can be really cool to see with this chart, right, is this is interesting but also kind of boring because it's just one line. But if you take referrer mapped, and you say you take referrer mapped and then you drop it on color, okay, now we have an interesting chart here where this is you have direct, you have on-site. But really, we probably want to get rid of direct and on-site because those are going to be kind of like not very useful. So what we can do real quick in this chart is we're going to just exclude direct and on-site because now this will give us a better picture, I think, of what we're looking for. So in this case, what we can do is this is an interesting chart, but one of the things that I'm sure y'all are aware of here is this chart is also not very useful in different ways, right? Because the scale, like this one point, this outlier point, kind of like blows out the scale of the rest of this chart. So what you can do, right, is you can adjust the scale here by going into if you click on the rows here of this count, you can go to quick table calculation, and then if you say percent of total, okay, you'll see that didn't quite do it. But then if you say compute using, and in this case you say event time and referrer mapped, okay, there we go. Now this is going to be this is a much more interesting chart, and you'll see like where the traffic is coming from, and you'll see like for the most part, like I never really publicized my website on LinkedIn back in the day. You can see like essentially you have a very clear picture of when I first brought on my website on the LinkedIn. It was going to be this July 2020 and that was when it was 50% of my traffic. This line chart is kind of ugly. I don't like this line chart. Let's change this. Can we do like an area chart? That's better. That's better. That's much better. So now you can see essentially where traffic is coming from various different sources. Like, so here's LinkedIn, and you can have a very clear picture of, okay, so in August 2023, 59%, right? You'll see that like for the most part, there is like Google drives a lot of my traffic, but so does LinkedIn. And then and then you see more recently, you can see these other platforms coming online. Like you see here's now Twitter is driving 12% and Instagram is driving 8%. And you'll see that like you can kind of see exactly how I was able to track my traffic over time. And so you can build really, really powerful dashboards with Tableau. It's a sleeper tool, I'm telling y'all. So this is interesting, right? This is an interesting kind of chart that I think we want to keep. This is going to give us a lot more data because you see how this gives us data across the board all the way back. So one of the things I want to help y'all to get you to this point again, right, is if you have events here, you can say compute so you at quick table calculation percent of total, and then you say compute using referrer mapped, and then that's how you get to this chart of like the actual percentages across the board. You'll see like there's a couple points here when like LinkedIn really dominated. Like you see here February 2023 and February and March here where LinkedIn was a huge proportion because that was like right when I announced on LinkedIn I was quitting Airbnb. But you'll see also right here in November 2022, that was also when I announced I was founding exactly.com Exactly Inc. And so that was like, you see another big spike there. But then, going forward, like you'll see, okay, you can actually start to see my Instagram efforts are starting to actually pay off. That's one of the things that this chart is being very obvious about, right? I mean, now Instagram is like pretty much as big as Twitter in some regards. And honestly, if I pulled the data one more time, Instagram would be absolutely insane. But anyways, this is essentially the idea behind one of the charts I would want to call. So I'm gonna rename this chart. This is gonna be called external traffic breakdown. Okay, so this is gonna be a great example of a chart that does tell a story. Like one of the things I would want to add in here, I think, is maybe add like, can we add a percentage in here? Does that work? Oh no, that label is ugly. You see, that's too much. That does not help. I think this is all we get. Oh, I know what we can do though. We can add a label for that. There we go. That is good. That's pretty good though. I like that because now you can kind of see the labels of everything, and you don't have to like look over on the right here as well. So that it makes the strain a little bit easier. So you'll see we have traffic breakdown. I think we have one more breakdown that we want to look at as well. And then we will be very close to having our analytical dashboard we'll have all the pieces of our analytical dashboard ready to go. So we're going to want to look at another dimension here. And in this case, I like, how many do we have for OS type? Okay. This is, again, something that we probably want to minimize a little bit here. I think like just having probably clumping like but Windows Phone is different, I guess, but like I kind of want to clump all of Windows together, but this is like probably enough because if we do a count here, what does the count look like? So if we sort here by count, okay, so we have other as the most. Okay, this is pretty good. I actually think the way we filter this data is different, where what we do is we filter by count, and we say we need at least 1,000 hits. And then now this is going to be a cleaner set of devices. So I'm going to rename this as this is going to be traffic by OS type. Okay, so this is pretty good. I like these 3 charts now. One of the things that you can do in Tableau, though, that is really, really powerful is you can actually create what's called a dashboard, not just a sheet. So you see down here, there's like this plus button gives you a new sheet, but the one next to it, this gives you what's called a dashboard. And I'm going to show you how you could do this. So this is a dashboard. I like to change the size of the dashboard where I don't have I have it just be automatic. I don't like freaking the fixed dashboard sizes. I like automatic dashboard sizes. So now we can then, once you have your dashboard open like this, you can start tiling stuff. So I think the traffic is probably the most important chart to put on here. And then really we have this one here, which is like our traffic by OS type, which really can be a little bit smaller because we want to see kind of that whole history. And then we also have traffic by source. So one of the things I want to show now, though, is this is where Tableau really, really shines. So if you go into more options, if you click into this, okay. So when you click on this, you'll see that there's this button here that says like use as filter. One of the things you'll see is now, let's click on Windows. Okay. So you'll see now we can see, you get way better. You see, I didn't even get really any significant, apparently everyone, there's wow, there's a lot of Linux people on Twitter apparently. But you can see okay, there's actually not that many people on Instagram from iOS or from Mac, but I bet from here, see, if you look at just iOS though, you see how there's way more Instagram people. And so you can really get a lot of great details here, right? I think that there is a missing chart here, and it's actually similar to this chart. So one of the things you can do is you can actually duplicate charts. So I'm going to duplicate this chart, and I'm actually going to clear the table calculation here. And in this case, we're just going to go back to a regular line. And this chart, we're actually gonna have this one. We're gonna call this total traffic. And we don't actually, I in this chart, I don't think we need to remove the filter because we can kind of have that as so why do we want this chart in here as well, right? So it is flattened here a little bit, but you'll see what you can do now is this is going to make everything dance. All right. You see how you can see how it dances, and you can see exactly where people are coming to the site and where people are but see, the problem again with this is I do think that this chart it gets kind of, the scale gets blown out here from these 2 points, the on-site traffic here and the direct traffic from in July here is too high. But you'll see one of the things you can do, though, is now if I click this one, or you can also use this one as a filter. And if I click this as LinkedIn, you'll see this chart becomes very boring because now this is filtered down to just LinkedIn, which makes sense. But now this chart is really cool. And then you can see, when like from LinkedIn, really like it's iOS and Android are going to be the most ones, and then there's a little bit of Mac. There's not even any like Windows doesn't even make the 1,000 cut, right? There's like a cut of like you have to have at least 1,000 to like even show up here, right? And then for Twitter, just iOS and Android, right? So like that's a great example here of like okay, like where do we go? But one of the things you'll notice, like with this external traffic breakdown, like the way this is set up is not really it's not that terrible. It really does have like a pretty good kind of, you can see how like that direct nature is like really, it's starting to like be like where people are getting sourced from different places as well. Like, and hopefully on-site gets more, that on-site would be a symptom of stickiness. But you'll see like the different points like where LinkedIn kind of like shows up, and how I've been kind of sourcing. Like this is like the cool thing that this chart shows, right? Is it's my social media strategy, but then you can cut to like whatever dimension you want to cut to, and you can kind of see where those users, like Linux users, right? Linux users like don't really come from Twitter or Instagram. We have four hits from Linux on Instagram, like total, right? That's like nothing, right? And then like you'll see that like but like with Mac, I bet it's a lot higher, right? Oh wait, it's 53, but still not very high. And like, but you'll like, because it makes sense that Instagram is gonna be more of like a phone based thing, right? And you'll see exactly like where different kind of pieces of the puzzle are coming. And that is the whole idea behind this, is you can bring in different charts, and you can bring them in and you can stack them, by the way. So we're going to put one more chart in here, which is going to be, we're going to have browser type. No. Well, it's fine. Browser type is going to be the same way, where you just do the filter, right? Where it's like, it's got to be like over 1,000 or something like that. Wow, that tail is like really long. Oh, it's because of all these bots, right? Okay, I think what we want to do is we want to get rid of the bots first, and just so, because there's all the traffic that comes from like Googlebot and stuff like that. So we probably do want to create a calculated field here. So create calculated field, but the calculated field here is easy. It's like if contains, and we can put bot, and we want to put lower here though, right? Lower. There's then bot, else browser type, and this is like was mapped. We'll call this mapped browser type. And so now this is going to be like a better browser type, right? So now you'll see, yeah, that gives us where we have like, we'll have just like, oh, see, bot is like competing with Chrome, right? And so now we have a better idea of kind of some of the stuff. Like really, some of these are probably going to be, we want to look at more together, like kind of Chrome is probably together, Safari is probably together, but kind of mobile versus regular Safari does matter, right? So we'll just keep it like this. I think this will be fine for now. We'll call this traffic by browser type. And then in here, well, we don't want this long tail because we really don't care. We will put, we'll put like, I guess we'll put that hard, like, maybe we'll just put like 100 here. I think I want to change the other one to 100 as well, because of the fact that there's still 100 for these. Wow. Okay, HTTP. People are hitting my website with Java. How dare you? Okay, but there's this other one that has this one. I want to edit this filter and drop this to just 100. The only reason for that is because I want to Windows 98. There's the GoFundMe people that you were saying. Oh man, yeah, we need a those not 130 hits of those guys on Windows 98. Yeah, they need a. Why don't they upgrade, dude? Like, what is going on? Like, what is going on in their life? Okay, so we have this traffic by browser type now. So this is going to be another one here. So one of the things that can be kind of troublesome with this way of doing things, right, is this is starting to look a little bit messy, right? A little bit like there's a lot going on here. And so one of the things that you can do is I like to like hide field label and hide field label and then hide field label here. because it's pretty obvious that this is what this is. Like, because you can edit this axis, right? And you can say like this is like this is traffic, right? And then down here you can say edit this axis to say traffic. And then here you can say edit axis and then make this traffic. Because really, if you make your dashboards beautiful, people are going to use them more. And now there's one more thing we can do to make this right side of the chart or the right side of this dashboard look a lot better. And what we can do here is you right click and hide title, because we just don't need the title. The title does not matter. And then what you can do is like essentially slide this up, and then you have all of this, right? So now what we can do is like we can look at see like, okay, if we go to bots, right? Okay, well, bots mostly come direct. That makes sense, right? Then you have like Chrome. Chrome is a lot less direct, right? But now look at this though. So we can say, okay, we want to look at people on Chrome and Mac OS. So now this is filtered down to only people on Mac OS using Chrome. And like you see how that's just like crazy, how you can like have all sorts of like, or you can say like Safari. Oh, well, look, it's only Mac OS. And now you can kind of see what that looks like, which makes sense that that's only Mac OS. But like Firefox is going to have a bunch, right? And then you can see all sorts of different charts. Like that's weird. Like, so people on Firefox and Ubuntu, I peaked back in October 2019 with this subsegment. Wow, dude, see, this is a story, right? And so one of the things I want to also show y'all though is there's one more thing that I want to show y'all is what you can do, and this is another important thing, is like I want to show you how you can annotate, right? So I want to annotate this point, and then I want to say I announced the founding of Exactly Inc. All right, and then wow, can we move this guy? Move him over here. That's like an ugly one, right? We don't really care about the that, right? We just want the words, right? And then this is like we can annotate here. And you want to annotate. Annotating is so good. Like so in this case it's I didn't announce I quit my job at Airbnb. And then this goes over. You can annotate, and then we have this last point here, annotate, and then this is I announced the launch of the V2 bootcamp. It's like stuck. Okay, so this guy needs to be moved over here, I guess, and then this guy could be pulled over here so he could be pointing. This is an example of what I call an exploratory dashboard. This is going to be the type of dashboard. Oh, wait, 1 second. We got to see the Windows 98 people. Okay, so they are showing up in 2023. They are, but they're mostly like, it's like they peaked in July 2022. They're pretty rare. I just had to see that. Okay. But anyways, the idea here is you can annotate dashboards like this, and this gives you a really good picture. Annotations are like, I am kind of probably mixing things together here that are not supposed to be mixed. So annotations are a lot more likely to be used in like executive dashboards than in exploratory dashboards. And we're going to make an executive dashboard real quick as well, just to show you the differences here. So if we essentially duplicate this chart, and then we take this out, and then we go back to the dashboard here, and then we have traffic, total traffic V2. And we just we want to remove these guys. We want to just stomp these. And then what we can do here is you annotate these points, and this will like announced Exactly Inc. Right? And so this point should now like actually stick around, right? Regardless. Yeah, there we go. It's because of the dimensional thing, right? It's the dimension's kind of hiding out there. But that's crazy. I like Ubuntu is such a crazy chart. Like it's like nothing. Like it was like 8 and then 2000 and then like 8 again. But anyways, that was the problem. Like the annotations can kind of hang around that way, but like I would say that that's how they should hang around with the filtering like this. Like you'll see they're not going to be too crazy here now. So yeah, that's kind of the idea. Anyways, I want to show an executive dashboard real quick because I think that one would also be useful. It's going to be similar to this total traffic kind of chart. I'm going to rename this total traffic no dimensions. I'm just going to call it that way. And what I want to do here is I essentially want to duplicate this chart. And what I want to do is I'm going to put referral mapped in here. And then I want to create a bunch of charts here. And you'll see why I'm doing that. So I want to like essentially have, this is going to be total traffic. We're going to call this Instagram. And we can duplicate this guy. And then remove this. And then we'll do Instagram, LinkedIn, and Twitter. We'll just do it that way. Keep only. Rename this. Total traffic. LinkedIn. Duplicate. Delete this. And then keep only. Rename. Nope. Why is it not renaming? There we go. Total traffic Twitter. Okay, so now we have total traffic. Actually, yeah, we'll just call it total traffic no dimensions. That's fine. So now we have a bunch of total traffic charts that we can look at that I think will be interesting. That will like, and oh wait, no, not a new worksheet. Go and make a new dashboard. New dashboard here, and then back to automatic size. And in this case, we have total traffic no dimensions. I think this is going to be. Then we have total traffic Instagram, total traffic LinkedIn, total traffic Twitter, right? And really, these should be like roughly the same. So now this is hopefully showing y'all like another version of this. Actually, I just realized there is one more traffic source that I really need. I have to have it if I wanted to really make this better. Is we need to put in we need Substack. Substack is super important. It's like put in the other category right now, but now that should, yeah, okay, good. Substack is there as well. So now I need that chart as well because I think that one will really make this pop. So if we do that, we grab this guy and we say keep only and rename. Why is it? Come on, Tableau. Don't do this to me. We got total traffic. Substack. So now if we go to the dashboard here, you'll see we can throw in the Substack one. And now it's like Instagram's is way too big. But so this is an idea. Like really, you might not even have the no dimensions here. Like you can because this isn't as important because maybe I just care about the actual growth of the individual channels, right? So in this case, it might look something more like this, where you have all the traffic that's broken down like this. I kind of want this to not be. This is terrible though. 1 second, let's like redo this because if it's 4, you want it to be 2 and 2, right? Not like like that, right? That's the best. See how that's like a million times better than having it be like 4 stacked in a line. So now this is going to give you a much clearer picture of like where things are at, right? And that is this, but like there honestly shouldn't be very many filters or clicks or interactivity. And this is the whole idea, right? And so this is showing me like, okay, like I obviously made some good improvements. Like you'll see Twitter is doing really great. Like Twitter's at an all-time high. LinkedIn, the problem with LinkedIn is that like I have LinkedIn pointing to my Substack. and that's probably why it's not as high. But you'll see Substack just came out with a freaking bang though. It's like at 2,400, like more than Instagram already. Right? So you can kind of like use these things to understand like where your traffic is coming from. And one of the things that you're going to notice here is that there is there's data here, but there's also way more that could be done here. Obviously, I slapped this dashboard together in like 5 seconds, and I'm not trying to say that I'm a super amazing dashboard man and can like do all this stuff the best way. But this is kind of the idea, right? Is that like, so the only other thing that might be in this dashboard is like you have traffic, and then there might be like a breakdown, like a percentage sort of chart that shows like percent Android, percent iOS, percent iPhone, stuff like that. Like you have like percent of total sort of thing. Like let's make that chart real quick. I think that'd be one more chart that would be in here. So in that case, we would be like, you'd have like, it'd probably be referrer mapped, and then you would have count, and then you just say compute, use it, quick table calculation, percent of total. Yeah, and then in this case, you would probably exclude direct and exclude onsite. And then this would be, I don't like it this way. I like charts that look more this direction. It's easier to read. And then this will give you kind of the percentage of each one of these. We see now there's Google is in this chart though, so we probably expect Google to be in the other chart, but this is going to be percent of traffic, total percent. So now this will give us our total percent of traffic, and we can move that into here. And this might be like right here. This is like, usually you want to put this on like the far side. Can it go over there? It might be able to go over there if I like. There we go. But now it's like squished, right? But like it should be like squished to this way. So then you can see you can hide this field label. Obviously you want to like, can you just like, does that do it? No, that's not what we want. Like, there should be a way to like, okay, you can edit the axis, because we don't really care about this axis because we know what it is, because it's in the title. So you can essentially go in, like, I hate some of the names that Tableau gives these axes is like really terrible. But like you can see how like you can really kind of make things pop a little bit. And then this is going to show us like a lot more data of like, oh, we really care about LinkedIn, right? And this chart is a little bit different, right? And there's this, the idea here is one of the things that you got to remember when you're building out dashboards is what story are you trying to tell, and like how are things coming across that way, right? And this is where you can get a lot of really good results this way by like, because this dashboard is meant to not be really interacted with, but this is going to be a dashboard that you can screenshot. So you might have some annotations here, like this annotation here. Like this is definitely going to be annotated, right? This is like quit my job at Airbnb and launched B1 bootcamp. But one of the things you'll notice, right, is like you see how I get there's a spike here for LinkedIn. There's kind of a spike for Twitter, but like Substack doesn't even have it because I didn't start Substack till June. And then Instagram, there's nothing, right? There's like essentially nothing. I don't even understand how there's one point back here. This point back here doesn't even make sense, like, because like I was not even like, and then it's just like no data for a year, and then there's just one point right here. That's so weird. But that's kind of the idea behind how you would build an executive dashboard that would just explain kind of at a high level. So like I could use this dashboard to like really monitor if my efforts were going well for my company and my social media efforts. So that's kind of the idea behind like what I had to present today. I want to open it up for some questions. If y'all have any questions around Viz or around like tooling or anything that I might do differently with this or anything like that, I'm definitely down to answer any sort of questions that y'all have, because like obviously dashboarding is not a huge part of data engineering, but if you can build things that look really nice, it can make a big difference, because that can give you a lot more visibility and help you get promoted. Because I know for me, that was a big thing that helped me get a lot more exposure when I was at Facebook, for sure.
Congrats on finishing the day 2 lab and the course. I hope you enjoyed it. If you like this channel and like this bootcamp, make sure to like, comment, and subscribe and share this content with your friends. I'm so happy that you're taking this time to invest in your knowledge and getting better at data.